Hi everyone, my name is Sridhar. I'm a software engineer at Brex. Today I'm going to be talking about Gradle-Backed Dependency resolution in rules JVM external. This is a brief overview of what I'd like to cover. I'll do a quick refresher on what transitive Maven dependency resolution or third-party dependencies with RJE or rules JVM external means. Most of you may already be familiar, but it's good to get context. And then how resolvers play a part with this process. And then we'll jump onto the Gradle resolver, which is the core of this talk, and why you'd want to use it. A couple of examples will illustrate that. And finally, I'll leave a few notes on implementation and potential improvements that can be done in the future. So you may have you have a JVM project maybe with Maven dependencies and Bazel. And there's a good chance you're using RJE with it. It's a very popular rule set. Okay, sorry. So typically what you do is in your module.bazel, you use the Maven extension, you declare a bunch of these dependencies you want, and then, you need to run a command to resolve or run the resolution and generate the log file to get all the transitive dependencies. A log file is typically recommended because you get to leverage Bazel's features like repository caching, the remote downloader, and integrity checks. And part of this process, as you can see, there's an attribute called resolver, which plays a big part under the hood. By default, it's Coursier, which has been the case for a long time. It works pretty well. But we'll also, now, that's a good segue for us to get into the resolvers. So as I mentioned, like Coursier. This is weird. Oh, okay. Sorry about that. Well, so the two resolvers that have been there for a while, Coursier and Maven, they're similar in the way they work. That at a high level, they look at POM files. So this is Jackson data bind, which is a popular Maven dependency. And they look at POM files as source of truth. POM files are the known part of Maven specification, and they have the transitive dependency versions and other constraints that are useful for the resolver to actually resolve and find conflicts or generate the final graph. So how does the Gradle resolver come in and fit in? Well, it also supports POM files because it needs to interrupt with other Maven dependencies. But it additionally can be used to support module files, which is what Gradle projects, producers of Gradle libraries, actually produce. It's also existing here, as you can see in this example, because Jackson data bind publishes both. And .module file is a JSON file. It includes a lot of Gradle-specific information that consumers of Gradle can use to do dependency resolution. A couple of them are variant selection and dependency constraints, and there's more. And most projects support both, or at least a lot of projects. And they work pretty well. But there are cases where POM files don't work very well, and we'll see those in a couple of examples. If I can get, okay. Oh, sorry. Right, so how do I use the Gradle resolver? Well, I just go and set the resolver attribute to Gradle. Also, maybe use a more recent version of rules JVM external. And just rerun this pin command, which will trigger the whole resolution process and hopefully work and generate the final log file for you using the new resolver. So why would you want to use a new Gradle resolver? Well, it sounds fancy, but what specific problems it actually solves? Okay, so the first example I want to cover where it's very useful is like an Android project. So this is a project that I scaffolded. It's very basic with Android Studio's project wizard. There's nothing really in it. It's all mostly scaffolded code. It comes bundled with Gradle. It builds, runs pretty well. But my goal is to get this to build with Bazel. And part of the process is there's a bunch of Maven dependencies that are used. Those resolve fine with Gradle. But I have these dependencies declared here. I set up the module.bazel. Now my goal is to do the transitive dependency resolution, because without that, I can't actually build the code. So So I tried it with Coursier, and I run into an avalanche of errors with transitive dependencies. As you can see here, I can't actually fit all the errors in the screen because there's too many of them, and I just give up. So I try hoping to see if the Maven resolver helps. Well, as you can see, it's literally an unsolvable version conflict. And part of it's sort of a different error, but also similar. And the common theme is that there's hard version requirements that come in here. And like when transitive dependencies are not aligned, it means Maven cannot really reconcile what version to pick. So where does this hard version requirements come? Well, as I mentioned, these resolvers look at POM files. In this example, like lifecycle process, well, it explicitly wants lifecycle runtime of 2.4.1, but through another transitive dependency, it wants a different version. Now it's very hard to reconcile. And another thing to note, these artifacts don't have a BOM, so you can't really like try to make sure the versions are aligned. Oh. Sorry. Okay, so now I try with the Gradle resolver, and it actually works. As you can see here, one of the artifacts that conflicted resulted 2.6.1. And well, why though? Well, a lot of these Android X artifacts are really optimized to work with Gradle, and they heavily rely on Gradle module metadata, and specifically the dependency constraints in it. So they don't need to look at POM files. The transitive versions are aligned. If you actually are curious, you can look at the example to see like the difference. And after this, I was able to like build the app and like actually get it to work with Bazel, which is what I wanted. So another example where it's useful is with Kotlin Multiplatform dependencies. So Kotlin Multiplatform dependencies are like regular Maven dependencies, but there's one subtle thing to note. Any given Kotlin multiplatform artifact or Maven coordinate is an umbrella that can be resolved to like a platform-specific variant. For example, OK HTTP is a popular HTTP client. It has like two different variants, like the JVM variant and Android variant. A variant with Gradle is really like its own coordinate in this instance, which has its own set of dependencies. So the Android coordinate or the artifact has a bunch of different dependencies because it has platform-specific code. Now, so if I try to resolve this with Coursier or Maven, it resolves fine, and there's no conflicts. But if I actually try to add this dependency to my build and expect symbols to resolve, it actually won't. Part of the problem is, well, it doesn't pull in any of the JVM variants, and also the base coordinate has an empty jar, which is the standard with most Kotlin multiplatform dependencies. Now there's a known workaround for this. You can pull in platform-specific artifact, especially like suffixing it with JVM and resolve it. But you need to first know that this is a multi-platform dependency. That's not always obvious unless you do your research. And additionally, like if you actually wanted to use Kotlin multi-platform with Bazel, and you wanted to like target other additional platforms and use some of those dependencies, this doesn't really scale well because there can be many native targets and other platforms. So now I try it with Gradle resolver. It resolves fine too. It's pretty similar, except for, as you can see, like the JVM variant already automatically resolved. Well, this is because we use Gradle, and we explicitly only resolve the JVM variant by default. In the future, if we extend to resolve additional variants, we can get those dependencies too, and have a single umbrella and expect it to work in a seamless way, which makes for a nice developer experience. And a brief note on implementation for people who are curious. How does it work? Well, when you actually add a bunch of these Maven dependencies in module.bazel and try to run like the resolution, we literally have to like run Gradle in a temporary working directory because that's the public API that's supported. Using the tooling API, we have like a build.gradle. There's no source code, but we have these dependencies. And then we have the dependency resolution is complex enough that we need to have our own plugin to do the resolution. As I mentioned, we resolve the JVM variant, and we also need to, well, Jules JVM external also supports AARs for Android artifacts. And then finally, we need to serialize and build the dependency graph, and that's translated to the log file. And finally, before I end, a few notes. On paper, it has feature parity with the existing resolvers. It's not yet as battle tested. It supports the JVM variant and Android artifacts. A caveat on the performance, it's significantly slower and in this current state than the other resolvers, especially so in larger repositories. This is because, well, we don't use any Gradle caching by default. There's a few PRs in the works to improve this. Additionally, you can turn on that environment variable to let Gradle use the cache on your system, which can significantly help. In terms of the future improvements, as I mentioned, Gradle variant selection is a big part of it, and being able to allow consumers to pick additional variants and resolve those dependencies would be a significant benefit, and performance improvements to make it palatable to use in a larger repository. And finally, I'd like to thank the maintainers of Rules JVM external for all the excellent work on the existing resolvers, which indirectly enabled building this extension for Gradle support. Yeah, and that's pretty much it. Thank you.